So correlation analysis basically is before we even go into correlation to get more about what it is, we need to understand that with correlation, we start thinking about modeling our analysis to have some statistical information. So we talk about general linear modeling, which is a technique that we use to establish the relationship between two or more variables. For instance, we can use it for predictive purposes. I may want to use one variable and predict another, right? Yes, and for you to be able to do that, there is a need for a relationship to exist between the two variables. And we may want to establish a relationship, but before we go there, let me ask a question. What nature of relationship do you think that will exist between exams, score, the time spent studying? Will they move in the same direction, opposite direction, or they will have nothing in common? So we say move in the same direction. What do we mean? Okay, what's your name again? The more time we spend studying, the higher the chances of the better score, right? Yes, that is the first ideology. So in doing this, we can use a scatter plot. Example of a scatter plot. A scatter plot helps us to establish the relationship, to be able to carve out the relationship that exists between two variables. On one hand, we may have our time spent studying and the mark we score in our exams. So in this slide, possibly we have three types of relationships that we can carve out. One, a positive relationship like what we have here, right? Yes, and this is like the supply curve. If no supply, what price and so this is a supply curve, prices and quantity supply. For those who are doing economics. Yes. So this is the nature of a relationship that we can have. Let's say this is our quantity and this is our price. So increase in price leads to increase in quantity supply, right? That's the idea. So that's one, the first nature of relationship. Such a relationship is considered to be positive. It is a positive relationship, meaning that the two items move in the same direction. For instance, somebody that practices, let me say, somebody have gone to school, or has gone to school, is more likely to score higher, maybe on intelligence coefficient, right? Yes. So which means schooling and passing the exams, they are related. So this is a positive relationship. The next possible form of relationship we may have is negative, inverse. As one of the items is increasing, the other one is reducing, right? As rainfall increases, what happens to the amount of plants? It reduces, everything being equal. So there is what? An inverse relationship. So that is what we do when we are trying to establish. So a scatter plot of this nature will help us to establish. A scatter plot at times can also help us to identify extreme values. Yes, for instance, looking at this, we may consider these points here to be relatively extreme because they are further away from this line. Normally, we call a line known as the line of best fit. We'll talk more about the line of best fit when we get to regression. Then we say there's a line, a straight line, right? So with a straight line, we have points above and points below. The further away a point is from the line of best fit, it means the further away it deviates from our expectation, because normally our null hypothesis is that all the points, since we're doing prediction, should fall along this line. Yes, we expect that our points should fall along a straight line here. So we tend to see some points below and some points above. They are further away from our line of best fit. And the last scenario is a curve of this nature. What do we notice? It's clustered and have no particular pattern, right? We can't see whether it's increasing or decreasing as one variable moves. So in such a case, what the data is revealing is that the two variables might not be very much related. Increasing one might have nothing to do with the other one. It's clear? No, it's not clear. It's okay. Are you sure? So there are, when it comes to regression, correlation, we have different types of correlation. We have the product moment correlation. We have the Pearson correlation, right? This is, the Pearson correlation is also known as product moment correlation. And we have the Spearman correlation. We have the Kendall correlation. Now, principally, what you will notice is that we'll use more of, or in most papers and in most studies, they will use either the Pearson correlation or the Spearman correlation. Now, the Pearson is parametric inclined, which means it's a parametric technique, assuming that our data comes from what? A known distribution, while the Spearman is non-parametric. So if you discover that the data is not parametric, it's not normally distributed, which means it doesn't follow the assumption of parametric, then what do we do? The recommendation is that we should apply the Spearman, right? In some cases, they may give you slightly the same results, but we tend to have a differences in the correlation coefficient. Yes, it might not be significantly different. So those are the two key, or the three key correlation. Even Kendall is also non-parametric. So the main parametric correlation that we use is a Pearson correlation, known as Pearson product moment correlation coefficient, often abbreviated as R. So, having said that, when we go back to our two variables are positive related, or they are negative related, but we have a challenge that we can't say for sure. Three things we are looking for. I think, let me say there are four things we are looking for. One, we want to establish first whether the two variables are related, right? If the two variables are related, that's the first thing. There's a relationship between the two variables. The second thing is that we want to establish if that relationship, the direction of the relationship. When we say direction, what are we referring to? Whether it's positive or negative, right? Yes. If you study, like she said, the more you study, the higher the score you can have, right? It means the relationship is positive. They move in the same direction. If the more you study, the less you perform, then the relationship is what? Negative. If the more you perform, the more you study, there is no effect on your score, then there is no relationship. So the relationship can either be positive, negative, or no relationship at all, right? When it comes to the direction. The third thing that we want to get from the relationship is the strength, right? In terms of strength, we're looking at how strong, how weak is the relationship, right? Now, the correlation statistics, most often people don't use covariance. It comes from the fact that when you are measuring two variables, right? When you're trying to examine two variables and they have a different unit of measurement. For instance, we're saying time spent studying. We can examine time in terms of hours. And studying now can be evaluated in terms of marks, right? So we have two different units. And so at times it's difficult to do a comparative analysis with such because the units are completely different. And when we calculate correlation coefficient, covariance, covariance, what happens is that the values, they vary. You can calculate and have a covariance of, say, let me say cov of 20. And you say, okay, there was a high relationship between the two variables, right? But when you calculate and have a covariance of 5, do you say it's low or not? It's difficult to, in such a state. That's why to get the correlation, I think they simply take the covariance over the standard deviation. And so they standardize the values to give them to the normally distributed. In that case, it suppresses the values to range between what? -1 and +1. So which means when you are doing your correlation analysis, no matter what happens, the relationship must be between -1 and +1. If you see your values out of this range, then there should be something wrong with your data or with the technique you have used. Is it clear? So we have given the third thing. The fourth thing now is whether this relationship is significant or not. Talk about whether the relationship is significant or not significant. So first, we establish whether there exists a relationship. 2, we give the direction of the relationship. 3, we talk about the strength of the relationship. Once we talk about strength, we are saying the correlation can be weak, it can be moderate, it can be strong, it can even be perfect. Weak, moderate, strong, perfect, or no correlation. So there are different possibilities. Significant, it can be insignificant or not significant. Any worry? Any worry? So if we have a correlation of +1, then we say that it is what? Perfect positive correlation. Many times you have a perfect positive correlation because positive correlation only exists between something and itself. You get it? Yes. But if you have a perfect negative correlation, it means the two things are opposite. They're really opposite each other. For instance, let's say the relationship between male and female. We just say it's positive, right? Either you are male or you are female. So you are directly opposite. It's not like you move side by side. Just to give us an example, maybe to help us understand. What's the relationship between income and consumption? It's positive. As your income increases, the more you consume, at least by all standards. The more you have money, the more you spend, right? That's the idea. So it's a positive relationship. But if that relationship was to be equal to 1, it means all what you get, you spend on consumption. You get? If it was exactly 1, it means all what you get, you spend all of it on consumption. So it's like something and itself. That's just trying to establish how you can measure. But now, if we look at the relationship between income and what now, that is negative. Income and come again. Savings. Yes. Well, actually, the relationship between income and savings is negative. Income spent on consumption. Or just income. Because part of income goes for saving and another one goes for consumption. So the relationship might not be negative. But if you say income, disposable income, all right, we know what disposable income is. Madam, what did you do in school? Sciences. Which sciences? Which subjects? We say sciences. It's also vague, right? So, which sciences, which subjects? Yes. So, you do not do economics, somehow, ordinary level. But we talk about disposable income at ordinary level, right? Income after taxes, which is mainly for consumption, or maybe you want to save, you can still save. But what we are trying to establish is that if we have a perfect correlation, either positive or negative, if it is perfect positive, then we basically assume there's something on itself. And we'll see that when we go to the application. If it is perfect negative, then it's something and the reverse or opposite. They move perfectly in opposite direction. It's like rainfall cannot go with sunshine under normal circumstances, right? So if there is rainfall, then there should not be sun. So we can assume that the relationship is perfect negative. But if it is that although rain is falling, there's a bit of sunshine, then we will have a negative relationship. The more it rains, the lesser we have sunshine. It's negative. You get that? Yes. And it can be strong, it can be weak, it can be almost close to 0. So, in order for us to examine correlation, we also have to test the assumptions. So what do we think can be the assumptions of correlation? What are the assumptions? I've put them here. The first assumption we have is that a what? Continuity of the variable should be continuous, right? That's the first assumption. The data should be interval or ratio. And we say correlation like the ANOVA, we say is robust. Remember there's a difference between a statistical technique being robust and omnibus. That's two different words. Right? Yes. Robust simply means it's less significant. It's not that sensitive to certain factors like assumptions. The assumption might not be made that much, but fairly accurate results. You get that? So in the course of using it, you can test the assumptions. They don't agree, but the correlation will still be valid. Homoscedasticity. Yes. So that if the intersection between points variables are plotted around the correlation line, this like the line of best fit that we saw, they will be normally distributed around that line. Some will be above, some will be below. Let's get back to this. So this is our line of best fit. Homoscedasticity says our points should fall around this line. Do you get it? which means we could verify this assumption using the scatter plot that the points fall along our line of best fit. Some of them will be above, some of them will be below. And I said if a point is here, then we might consider this point to be an outlier because far away from our middle line, which is known as the line of best fit or the correlation line, as correlation will put it. Then the last assumption is that the relationship between the variable equation can be adequately portrayed by straight lines. It still goes back to support what you just said. Now, should it be normally distributed? Yes, you will expect that there should be normal distribution to an extent, no significant outliers. But the scatter plot helps us to also identify significant outliers. Now, apart from our relationship taking on this form, this, or this, we may equally have other forms of relationship that are worthy to mention. Maybe something like this. All right? This is kind of exponential, it's not linear. Covariant, covariant relationship, something like that. But it's exponential, which means it doesn't follow a straight line, right? We may have another one of this form. So this type of relationship, they're not linear. So we cannot use correlation to examine them. There are other techniques that we can use. So our interest with correlation is that the relationship must follow either a straight line, right? Yes. It could be a perfect relationship, maybe like this. Perfect positive, perfect negative, whatever. Remember, for those who have done economics, to understand perfect demand, imperfect demand, also things of that nature. I'm not an economics student, so don't expect much from me as economics is concerned. So having said that, any question? Do you have any question? Pardon? I said there has to be robust. The data. I'm not sure. Say something like that. You didn't get it. I said correlation is a bit robust, not the data. And what I meant by robust is that it has the potential to give you valid results even when the assumptions are not fully met. That's what I said. So let's open our data set that we've been using all along and do the practical part of correlation. Today, sharp. We're already senior statisticians. Nemo, welcome. You were late again. Who is responsible for such a work? Okay. So now certain things you need to take into account when you are dealing with correlation. That maybe I've not mentioned, but you should take note of, which now helps you to understand how statistics works based on the output, the outline that we have tried to give you. When we started with chi-square, right? And we said chi-square, the data was categorical. It can be nominal or ordinal, right? From chi-square, we went to the one sample t-test, which we were dealing with a single variable. And there, the data was continuous, but we had just a single variable. We went to independent sample t-test. If you have been careful, you discover that with the independent sample t-test, we have one variable which is continuous and the other one categorical. A similar situation for dependent sample and therefore ANOVA, right? But the correlation now, the condition is that both variables must be continuous. Now, there is a type of correlation that takes on a continuous variable and a categorical variable with two outcomes, known as biserial correlation or point biserial correlation. Point biserial correlation. In which case we can have a variable that is categorical, but the variable must has just two options. I don't know where it's half or has. Right? Must be two options, like 1 and 2, male and female, pass, fail. It's possible for us to still use correlation to examine that. Do we get that? So that's one thing that we must take into account, that for us to use correlation, our two variables must be continuous. Our two variables must be continuous. If they're not continuous, then they are not ideal for us to use correlation, except the variable is by dichotomous, right? Which means with two outcomes. Some will call it a dummy variable, which means one or two outcomes only. We can equally apply. But in that case, we must have one variable that is what? Continuous. So, in other words, you see that we started from categorical to one categorical to one categorical, one continuous, right? We're now with what? Two continuous. Do we get it? As we move into regression, it's called that we may need more continuous variable, more categorical variable. So that's how this training has been arranged, so that you see how the variables, they progress from one level to another. So now, let's analyze the relationship that exists between weight and height. But what's our expectation? All of them are continuous, right? So what do we expect? Your height increases with weight or it reduces with weight. So short people who weigh less than tall persons. Is that what we're taking? Well, the next, what do you think happens? What's the relationship between height and weight? Do you get us? Top people are is he there asking the person like,
hello, sir.
My screen is not shared. There's the data now, you have the data, so even if they don't share. Yes, we're asking you, what do you think will be the nature of relationship between weight and height? Will it be positive, negative, or no relationship at all?
Oh, okay. I think it's going to be.
You're going to be? We didn't get to. Okay. So let's try and see now. To run it, we go to analyze. From analyze, we take bivariate. There are different types of correlation. We've been interested. We have partial, yeah, canonical correlation. Canonical is what? Canonical correlation. I rarely use that one. Sure. Yeah. So we take bivariate. That's why I say we have the Kendall, Tau, and the Spearman. So let's assume that data is normally distributed, comes from a known distribution. We transfer the two variables into our variable list, and we take, okay. So from there, we have our output. This is our output. So we have our output. Who can interpret the output for us? We cannot. So with our output, the first thing is that what we notice, we have height and height, right? Height and weight. So the relationship between height and height is 1. That's why we say something and it says the relationship is what? 1. And that's considered as perfect relationship. Now we have height and weight. The value is 0.513, giving us what? The correlation coefficient, which to an extent measures the strength of the relationship. So since we said relationship is between -1 and 1, this value is what? 0.5, which means it's positive, right? Meaning that height and weight, they move in the same direction. Now, it's important for you to note that correlation talks about relationship, not causality, right? That with correlation, what happens is we are establishing the nature of the relationship without necessarily saying which variable is causing that relationship. So if you look at this table now, we have 6 value, which is 0.0000, meaning that first, there is a significant relationship between what? Height and weight. Do you get it? The relationship between weight and height is significant. First, the relationship is positive. 2, we have a correlation coefficient of 0.5. And based on the scale, this is considered a moderate relationship. Now, if we go back, a relationship, if the value was between 0.01, maybe to 0.4 or to yes, let's just say 0.4. I don't have the exact scale, but it's just an estimation. We'll consider the relationship to be weak, right? If between 0.4 to about 0.6 or 0.7, we consider it to be what? Moderate. From 0.7 to maybe 1, be strong relationship, right? A strong relationship means those variables are closely related. It's like a twins, a relationship between two persons that are twins, they're very tight, right? Though they come from, if we go to a family and see we have the first 2 children, they're twins, they always like to do things together, right? And so you look at the relationship between twins, we can consider it to be strong, but the relationship between twins and the other siblings might be what? some are moderate, right? And the relationship between twins or yes, twins and other family members be weak, right? The further away they move from being too close, the weaker the relationship. Such that the relationship between brothers can be strong, and the relationship between brothers and other families may be moderate. The relationship between brothers and outsiders is weak. You get it? Yes, just trying for you to understand when we say relationship is strong, weak, or moderate. So in that light, since correlation is what? Symmetric. Symmetric means we have equal on both sides and left. That's why we see that in SPSS will give us both the upper part and the lower part gives us the same thing. If we take weight first, we have the same results. If we take height, we have the same results. You get it? That's why here now they have weight first, we have the value, this, and so it gives us the same outcome. On this table, we have 1, the correlation coefficient, which is this value, significant value for our n, right? We have our n. And then we also have the perfect relationship. We must always have this perfect relationship here using SPSS, because they always have give you the relationship between something and itself. Is it clear?
Hello, sir.
Yes, establish relationship, but not causality. So, having said that, let's test for which variables now. Let's go back and check. What do you think will be the relationship between
Let's test English and reading.
Okay, let's test for height and reading. Reading. What do we expect? Increase in height, so increase in ability to read. Don't realize to sleep. So let's test now. Okay, somebody says some people like to sleep. I'm a tall man, I don't know why I like to sleep. Am I not tall? Yes. Tall people like reading. What do we notice? What do we notice? My screen is shared, right? So, first, what do we, are the two variables related? They are not related. Are they related? They have a negative relationship, which means as height increases, reading reduces. So we're supporting the line. Are you sure? I did not see this. But then we don't have enough evidence to think that height and reading are that much related. That relationship is insignificant. 1, supported by the fact it's very weak. 0.00 is really, really weak. Right? If it was 0, it means that if we wanted to round down my n number 0, which means that 2 are not really. However, there is a relationship and it's negative. So let's take now, we're just doing now, it's Let's check for what again now. Let's see whether we can find another interesting relationship. So rating and the weight. What do we expect? Meaning? Assumption fails. It's like this is telling us that the more weight you have, the more you rate. The relationship is positive. For me, it's positive. Maybe yours is negative. And it's somehow stronger than even the height. Although still insignificant. Right? So let's go and check for another interesting relationship again. Which one do we think that will come up? Speed is like how fast you can do something. Let's take reading and writing. The sleep time, yes, the sleep time. Yeah, I think it can give us a better. So let's take that sleep time and reading and check. What do we notice? Meaning that, yeah, it's not strong, it's weak. So let's plot our, before we do that, we need to go back and we needed to start with the scatter plot. I forgot about the scatter plot. So to add the scatter plot, go to graphs, legacy, dialogues, and go to scatter plot. So it's just a simple chart. We take on this and we take define. Now, what is our X? Let's just take let's take the first one and our Y. And we may decide to do this and check. Do we think that smoking will have something to do? I'm just asking. So, scatter plot, define. Let me just remove this. I will get a simple chart here. So, what do we notice? Who can interpret this chart? Who? There is a positive. What makes us think that the relationship is positive? So to help us, let's put now the line of best fit. So this is a line, right? Showing us the direction of the relationship. We said there will be points above, there will be points below, right? Yes, and this is the line of best fit, giving us this. So it's a scatter plot. You use it to establish whether two variables are related. So let's get another scatter plot now for a variable that we discovered that was not related that much and see how it will be, it was what? And height. Let's say reading and height. What about English and reading and height? You see the difference? You can't establish a specific direction. So, but let's still try to put the plot and see fit line. What do you notice? The relationship is not linear, right? It's not linear, which means the two variables are not related. They're not related. They're not related. It's just scattered everywhere. So we cannot really see whether it's increasing or reducing. Professor Nemo, are you adding? Okay. So from here you become professional. So let's take again for where can we get which variables have negative relationship? We have seen positive. I want us to get negative. Which one gave us negative? That's significant because if you take something that's not sleep time, was it significant? Let's take study time and reading and see. Study time and no, let's take study time and maths. We expect that relationship should be still be positive. We expect a positive relationship. But strangely, let's verify. I did not see this coming. There's not this possibility that they are not related. But the relationship is very weak and insignificant, right? The more tilted the line is, the stronger or the weaker the stronger the relationship. It can be negative or positive. You get that? If the line is just flat, that's what the possibilities. So what are we saying? You can go and explore other possibilities.
Hello, sir.
Any question? So are we comfortable with regression? Correlation. Should we go to regression?
Hello, sir. Hello.
Which one? This one? Yeah, you go to plots, legacy, scatter plots, and you define them, set markers by, you can take anything you want to see. But you may want to segregate, let's say take markers on campus and differentiate between gender. I can put gender here. Let's see what we get. So we'll see that they will plot for gender separately and for male, female separately, and then they will also give you the possibility. So it depends on what you're trying to get. Right. So before we let's do a quick review. I have a data set here. I want us to just GSS is a general survey, annual data done by the US. What happens is that there are so many questions. They do it, I think, every year. And they ask a lot of questions about different things in the society. Don't know if you can see my screen. I tried to share the data, but it was a little bit heavy. You can download it online. So it's something that's done every year. If you look at our data here, we see that they ask questions like the labor force. Let's see what are the options. We are working full-time, working part-time, that's temporary but not working, unemployed, laid off, retired, school, keeping house, others, and maybe doesn't apply. Those are different options, right? So I don't want us to analyze this data, but I just want us to see some certain things when you are inputting your data and possible questions that cut across, just to see how to set questions here. There's so many things that I'm asking. But when you are doing analysis, you don't analyze. I have a whole data set, but what are you driving at? It's not like all the questions that you have, you must answer them and put them. No. For instance, if I look at this data, I see that they're asking whether somebody's working. They have even asked number of hours, number of hours worked last week, number of hours worked a week, and so on and so forth. And as I check through the questions, I find something interesting. Father's occupation. There's a part that I wanted us to. They're asking about drug addiction, improving highway bridges. There's so many things. There is one on a controversial topic that I wanted us to look at it. To see it. This one is talking about divorce. Divorce laws, what do they say? No. So let me ask a question. Do you think that it's good for somebody to commit suicide? If you are unhappy with life, won't commit. Will it be recommended you commit suicide? Why? It doesn't belong to you. Okay. So look at the type of question they're asking. Favor making, allow incurable patients to die. What do you think? We should allow people who have disease that cannot be cured to die. Sonny, should we allow people that have incurable disease to die? We shouldn't. We should allow them to die. Or let patients die if doctors agree. It's a yes or no. Suicide if incurable disease. You have yes or no. This I don't know. We equally have suicide if bankrupt. Should people commit suicide if they're, or will you commit suicide? These are more personal. Will you commit suicide if you are, you understand? So will you commit suicide if you are bankrupt? In Cameroon, I'm say no. Should I commit suicide if, okay, there's family besides you. So the situation is different. Should we allow shotgun at home? Yes or no? What are the type of questions they ask? Because across almost everything, the data is heavy. I wanted to send, but the part that was, okay, I wanted also to look at it, was this issue of abortion. It's a highly politicized issue in America election. They say that abortion, if spouse, should you commit abortion if your spouse refuses? Yes or no? Abortion if spouse opposes should not, should not. Answer yes or no. Abort. Do you agree or not? Disagree? You shouldn't. Abort if abortion if held. You should have abortion if probable defect, which means a child might. Yes. Okay, let's just check. Have abortion if held endangered. Yes. Why? Have abortion if couldn't afford a child. Could not afford a child. So, have abortion, should abort ever before? Should abortion be legal? Okay, let's go and run just frequencies and see something. And see how people's opinion varies. That's under abortion, right? What do you think? It should be legal. Why? No, but if so, which means legality depends. I can't even look at the questions here. So, if we take the argument of you have your right to, what about the right of the child? Or the child doesn't have any right? And the question, when do your right become your right? Okay, I think I've seen the questions. Let's just run frequencies and see how humankind. So, we go ahead and abort if husband opposes. According to our findings, 28% participants say yes, while 71 refuses. Okay. The next question is abortion if probable defect. Looking at the same question, which is still on abortion, 75% of the people have changed. They say yes. But the next question says, have abortion if held endangered. We said the opinion now changes to 82 who agree that people should. Let's go. Have abortion if couldn't afford a child. People don't think that you should. Yes. It's not enough reason. You are not able to afford for the needs of the child. Which family members? How many children have you taken? Okay. Should abortion ever be legal? We say always 22.1 say yes, say 8.9 says no, and some say never, 9%. But if you go and check, if you want to correlate now and see, because this is what data analysis does. Yes, some people say never abort, but if you correlate the views of the people say never abort, and should abortion be legal, you discuss people are mentioning never. They have said that if probable effect, you should abort. So as a data analyst, when you are asking questions, you must be very specific, right? Yes, because the answer, the responses you get to an extent will be influenced by the way the wordings of the questions. If you just say abortion, should abortion be legal? Maybe everybody will say no. But if you say abortion should be legal under certain conditions, we discover that maybe the people now will accept that yes, the opinions vary. Even people who say no, some people think that okay, if there is possibility of defect, you should abort. Some people think that maybe if the woman's life is endangered, you should abort, right? But some will still refuse that even when the life is endangered, a woman should keep the pregnancy. But there are other ways they can remove the baby. What I was saying. Pardon? Why should help? This one is I strongly agree. Why should help husband's career first? Yes. Wives, the wife should help the career of their husband should be the first thing you should be concerned, not your own. People like Sandra will not agree to this question. Sandra cannot accept. I think that's an answer will not also accept. They're career oriented. Oh, no, now it comes back to we have career oriented wives and let me say home oriented wives. Let's assume that man is very generous. Why? So why do you work? All human beings change. Yes, everybody has the potential to change. So who on your career first? Why? So if they give you everything, you will not work again. Like seriously. Yes, give privacy to it. Okay. So, what are we trying to establish? There are lots of things that you can research. A lot of data online you can use to practice, right? Yes, you can use this. I won't tell you that everything that we have done covers everything. But if you lack data, just this data can give you a lot of information. Depending on what you're trying to look for, there are a lot of things. And somebody who is interested in the economy, you can find questions related to the economy. You want to help you. Yes. See the format of questions that are asking, maybe the coding pattern. We talk about missing values and those things. Yes. So it is very, very important. Data is everywhere. You can generate your own data. For instance, you're able to generate data, right? Or you look for data or use the one that we have been practicing with. But like I said, the issue is not the data set first. The issue is understanding the principle behind the data. The key things that when you pick up data, what are you looking for? What is the data? What is the measurement? Especially measurement levels, right? Based on these measurement levels, how many variables are you working with? If I'm dealing just with one variable, what possible analysis can I do? If I have two variables, what is the level of measurement, or what are the possible analysis I can do? If I have three variables, what possible analysis analytical technique can I use, right? Depending on what you are looking for. Such that you should not think that maybe you limit your potential to other data sets. No. All data will take on these different possible formats. So with that said, I will not want to start regression today because regression is a heavy duty, kind of heavy duty. We need to take it slowly, but we'll start building from what we have seen here, from what we have seen on regression, which has to do with relationship. So we'll build more based on that. If you want the data set, you can bring your flash. Since I said I cannot, it's difficult to upload it online. So having said that, any question